Welcome everyone to some more real level development here and Linux and open source on our channel with our now overclocked CenTaur CHA-001 processor, as prototype previous video, right? And so we are now running overclocked because obviously we do. Here this was binned at 2.2 but now runs at 2.4 because performance. Only substitute for performance is more performance. And in the previous video I speculated about the CPU temperature sensor, and of course I tried to patch that, and lo and behold, you see it here already, 48 degree, that works. I slightly wonder if sometimes actually I wonder if they have 8 sensors or if just the time difference reads slightly different values. Anyway, so yeah, so that works here now. So what have I done? As I mentioned in the other video, via CPU temp, and so that worked. So what I basically did is patching here this family 6 CHA, and I'm a little bit surprised. So apparently what the cooperation of CenTaur and CHA-001, comment below how I should actually pronounce it. So to my surprise they patched this here, because when I'm working with this I was wondering, wait a second, why does this 2019 prototype from CenTaur identifies, actually do I have this still open? I have this still open in my own CPU stuff here because other stuff was confusing. I probably should actually check my own code here, but anyway, because this expands to not 7 but 47, so whatever bits. Although I think the Linux kernel also, oh wait, this is 30, wait a second, 31, is it even 31? Let me check that. So yeah, I had to add this define, so they have that not in this file. I find it a little bit, they have here some include ASM. The problem is then that you have here different stuff. Is it even including other? I slightly wonder why they have this CenTaur here and they have here Intel family, but yeah. So 47. All right. So probably 47 hex wouldn't surprise me if that substitutes to 71. What did I say 41? 65? Did I even say, whatever, did I say that? 47, what did I do? 47, that is, yeah, probably that is 7 more 6, yeah, 71. Did I say 71? Probably. Good to fact check that, yeah, so 71. That adds up, so, because what I was wondering, vendors being vendors mean obviously you don't reinvent this interface stuff unnecessarily, although sometimes they changed it. So it required of course some messing here of model x86 7 and switching that there, model specific. So how this works is reading a model specific register, in this VR case 1423, would also with previous like C7 of decades ago, this is 32-bit, very low performance stuff. That was another register. I always wonder, how does it happen that the vendors decide like YOLO, let's change it from one model to another, but Intel and AIM do the same, which between K6 and Athlon and Intel Pentium 4 and Core and constantly. Sure, there's always like better sensor, better ADC analog to digital converter resolution and stuff, but it's like, yeah, why does it constantly change? So yeah, need to add this here to this matching table that is here, and how that works is there is some Linux kernel specific x86 match CPU thing, otherwise you get Eno device. Obviously I got Eno device, right? So I patched this in there, and in retrospect it's not a surprise that this works, because looking at that here 2018, or this interestingly enough is some even year before this CHA. So I slightly wonder why with their partnership with CHA-001 CPUs there in China, where they apparently sold some or licensed some technology. So they use 7, although probably like, yeah, their new model, whatever they modify, Model 7, because that is still like later 2019 than their own CHA, still Model 6. But anyway, also the licensed Model 7 there of CHA-001, so is also still using the same model specific register. So the values here look plausible, so yeah, 49-ish. I think it's, so I have a spare NCORE, whatever, tiny fan on here. I can, like on the fly, how hot is the heat? The heat sink is nothing like, wait, why is this interesting, this bloody low noise adapter is getting warm? That is, where is it? Nothing like here, the NCORE. Low noise, it's probably getting hotter, right? I unplugged the fan, that is always just what you do on your live streaming setup. Yeah, 50, sure enough, so now it's running without this NCORE. Surprisingly, probably just a freaking resistor, yeah? Because this bloody heat shrink cable is getting freaking warm. I mean, not hot, but... yeah, I mean, what else should be in this NCORE NARC7 low noise adapter? What else should be in there than a resistor? Anyway, so yeah, 47 before... 49, 40. Yeah, anyway. That's basically for this video. Of course, T2 being the only distribution getting this patch, then I probably could theoretically eventually send this upstream. But in case you're wondering, like, of course, also best without this print K actually, because my first copy and paste with the wrong model number with hex and stuff. Print K, of course, didn't work. Of course, you do this, debug this with good old-fashioned print F or K. Probably looks good to ship to the many prototype users out there with this AI accelerator. Obviously, soon they run all T2 anyway. Because, so Linux, that is via CPU temp CHA. And so that's how you do it, right? It's a totally small thing, but even that took probably 20 minutes of trial and error while unpacking that, manual building that here in the source tree. And first didn't work, like copy pasting. It's like, yeah, 5 minutes there, 5 minutes there, it doesn't work. Print K there, all that is the wrong value. And so on, hex versus not hex, and then it worked. So then we probably want to commit that, right, for probably no one. Playing along at home, CPU temp. And if you are one of those developers and are triggered or happy about that someone still archives that for the future, just because, and you have NCORE, because obviously I next want to program the 32,536 or so bit AI coprocessor. So if anyone ever listens that, even in some years, coming across some specification, happy to implement some open source code, or has some patched LLVM sources lying around, or other fun stuff. Anyway, that's basically it for this video. Just another patch. What other random garbage do I still have here? Via CPU temp, I probably patched Linux kernel 4 via, or patched via I guess like that. Patch Linux kernel via CPU temp driver for that. Probably should have proofread that, or actually test compiled that. But anyway, that's how you do stuff if you are getting started with also pro tip, proofread and review this stuff before you freaking commit this. So then we can clean the sources. Yeah, I didn't run the config. I have to say the USB is, I mean, previously USB ironically was often a little bit glitchy. With VRC7 and stuff back in the day. Ironically, I didn't have any USB issue yet with this prototype board, in contrast to the freaking AMD AM5, right? It's a 17950X. I have plenty of USB glitches on various USB ports. And actually, the other thing, the other video, right, with the failing Ethernet, on the, what was it, Intel 2.5 gigabit, previous video, Gigabyte X670E, and thanks for the super chat, I'll read it in a second. The Ethernet was totally glitchy and totally slow, and later that day I even got a Linux kernel printout of Intel ICA or whatever driver PCIe link lost, right? I think I never had that in my whole life. So much to via prototype board actually working, and latest and greatest AMD AM5 gigabyte Aorus Master X700E. It's like USB glitchy, PCIe glitchy. I hope they solve that. Lael wrote, what benefit will distributions or will distribution of any other distribution will this distribution offer over any other distribution? Actually, the chat before. So benefits. So this distribution T2, right? I run this for 20 years. This was formerly known as Rock Linux, which Claire Wolf founded, and I now continue to maintain as T2. I was at Rock Linux also one of the main maintainers. So this is one of the major source distributions. The other one is Gentoo. We are just a little bit lesser known because being at the wrong time at the wrong place and right time at the right place, right? So Gentoo got usually more media coverage, and what T2 offers is sophisticated cross-compilation, right? And building targets. I'm not sure if Gentoo is still, probably there is a cross-Gentoo, not sure how integrated this is. Like years ago there was a cross-Gentoo, or there's also build root and Linux from scratch, but what T2 does is automating all the stuff, like unlike cross-Linux from scratch, which is more a handbook. So T2 has sophisticated cross-compile support, so I built 26 ISOs for everything from ARM to RISC-V on x86 latest and greatest stuff here, and also allows to group your stuff in targets. So if you have an embedded target for your embedded device of environment control, self-driving cars, robots and stuff, or phone and so on, theoretically Steam Deck or your company like Tesla SpaceX and shipping this stuff, probably should try to get into NASA's RISC-V initiative. But yeah, of course you can build with Arch and Gentoo, but with T2 it is not only nicely shell scripted, like readable shell scripted, but also you can group your stuff in targets. So you actually, I wanted to test build this here. So what this means is that you can keep all your patches and modifications at one place, to version independently of T2, which I'm not sure many other support. I mean, again, people use Arch and Gentoo to build some stuff, but the last time I checked, they didn't have such kind of target. We have some examples. I personally use mostly the generics. There are some other old examples. We probably should clean it more up. But so you can have there like one directory with all the groups of all the patches. You want to ship something, you modify something, you patch something, and all your other custom, like you want to disable some options and so on. Yeah, you can group all of this here in one directory and so on. And yeah, otherwise supporting all the architectures, including never released prototypes and stuff. So yeah, thanks for that super chat. But otherwise on this channel we also do other, for example, we keep SJ Octane stuff alive, P3 stuff alive, and similar such stuff. And increasing our vintage and retro collection and other prototypes. What is the temperature during 46? So what is that? So this is without, so yeah, it is, I would say 4 degrees, up to 4 degrees cooler with the Nocturne fan running at full speed. Yeah, that was a fun thing. I wonder if ever, like, if you ever want to hear about this again, I will make a proper review on the more main channel. And if I ever, even if it's in 5 or 10 years, if I ever get documentation of the NCORE, like the AI accelerator coprocessor here, of course we will mess with it. To reverse engineer that, we would need Windows drivers, but I guess nobody outside CenTaur ever had this. So I don't know of anyone who has documentations or drivers to reverse engineer, unfortunately. And without that, you could of course randomly poke the PCIe memory space, but that is of course somewhat cumbersome. I slightly wonder, oh, we had in here, I wonder though, I wanted to check what is the memory mapped space here of this coprocessor. So that is 16, this is NCORE coprocessor, and why is the segmentation faulty? Actually, I had that on this is probably not, and thanks for the next super chat. Did you start with Linux from scratch? No, I didn't. I'm not even sure when Linux, so I do this Linux stuff, I said this a couple of times, but due to your super chats, I repeat that for you. I do that since 1996 or so, so I'm graybeard Linux stuff when I was still in school. And at that time there were not this 1942 Linux solutions, maybe have been, I don't know, 2 dozens. And I started, did you start with, so we started with Rock Linux, right? I think Claire mostly wrote this from scratch, and I found that really relatively early, like Rock Linux 1.2 in 1997 or so. And welcome everyone. And I got to Linux by accident. The first thing I installed was Debian in 1996. It was so garbage. As I grew up programming in DOS, right? Since I was 8. My neighbor and I, we programmed Turbo Pascal and Turbo Assembler, basically played around with demos and games and some graphic effects and stuff. So we did low-level stuff in DOS. So we knew assembler, we knew Turbo Pascal, and we didn't even, that was before the internet in the 90s, before normal people had internet. And so we discovered Linux by Linux magazine discs, and the first was Debian, and it was so annoying to install in 1996. We were like interesting in concept, but like, oh my god, is that a garbage operating system to install? Then we found SUSE, the German Linux thing there, and used that. That was like better than Debian, but nah. And like within a year we were like, yeah, that is kind of nice, but oh my god, is everything not very amazing. The device like not plug and play, and X3 3 or 2 or who knows what, Linux kernel probably 137 or whatever that was. So basically then we wanted to start an operating system or writing all distribution. Then we accidentally, also due to a magazine, I guess it was like FreeX was the magazine name or something, there was a Rock Linux CD in there, and then I started with Rock Linux 1.2 in 1997-ish or so, and that was like a time saver because it was like, of course, not as sophisticated as today. Why is here? This is a LSPCI. But it was mostly how I anyway wanted it. So basically what Rock Linux was is building from source, and it was like mostly how I thought, like, hey, finally someone wrote a properly Linux build environment thing in shell script that worked for the most part and so on. And so that is why we didn't start with, so I started with Debian and SUSE. That was like meh, like using it, 16-year-old, and then we moved on to Rock Linux, and the rest is history. And since then, so basically I maintain my distribution on like Claire's Rock Linux, and that is still today T2. I maintain that for already 25 freaking years, right? Which is obviously a crazy amount. And now with this YouTube channel, obviously, and all the crazy work of SG Octane, PS3, and all the architectures, and basically epic thread wrapping, cross-compiling, everything here live on YouTube since 3 years, obviously regaining quite some more market share momentum here. So PCIe util depths, and we will obviously usability is not yet This is actually, I had something similar on another. So yeah, PCI util. This is crazy stuff. Why I theoretically want to write a microkernel, right? Because 2022 and stuff segmentation faults. It is rather silly. Was a device specifier like that? Sometimes it is. Sometimes it's minute device ID. Yeah, thank you very much. What would be the device ID, or is it? What does it want there? Basically, I only want one device. Let's see if that segmentation falls. Which also, yeah, recurring theme 2022 and like basic PCI stuff. The segmentation falls. Show numeric IDs. Where's even freaking device name switches? Show domain numbers. Show kernel driver handling each device. Select the device S, domain, bus, function. Okay, we probably want S. Segmentation fault. Yeah, that was. But okay, so this coprocessor has a memory bug. It's actually disabled because there's probably no driver. I wonder. I mean, this is a little bit large, so that's registers in memory. So I wonder, this has 16 megabyte of memory. I wonder if you enable this member, this memory basic register and memory window here, if you at least could use that 60 megabyte as super fast tempfs or something, at least until we ever find documentation for this device. But anyway, I wonder what is the freaking difficult to write in PCI list thing. It's, yeah. What else did we want to do? Alright, I wanted to test compile. Actually, I should have done that before we commit that, but so Linux and then yeah. So actually, so I found on the internet some other people who have such a prototype. CenTaur holds CHA prototype. Managed to overclock to 2.5 gigahertz. Mine is not stable. It boots, but Geekbench crashes. I auctioned or brought from this liquidation auction 2 CPUs, like one board and 2 CPUs. But my understanding is the second CPU, which I've not yet tried, is lesser binned. At least that is, I think, was the communication. I will try that another day. It's not the most important, but yeah, I mean, who cares? 2% of whatever. What even is that? 2.5 of 2.4, 4%. Fair enough. Maybe 4% faster. Yeah, but 4% faster. It's not worth it in burning this precious prototype CPUs, obviously. Just get a phone call, of course, like I usually do. So, of course, just a regular call. Hope that was muted. And so yeah, this patch applies to this. Yeah, I probably should send some more useful things like this upstream sometime soon also, but again, it just takes so much time. Just send like easily 30 minutes, right? Creating the patches like a fraction of the time of looking at the people, formulating a nice email, making sure you send the text, like text inline, that it doesn't white space damage and stuff, and deal with all this back and forth. And then you spend your precious lifetime, and then they don't want to apply it because now who cares, prototype and whatnot stuff, like, which I at times don't really send the stuff upstream. Which, by the way, reminds me, we could use it as a win-win of this often stress. I probably should automate some stuff here. Let's see if they have a 520, because we have an, they don't have yet. Good. I also have this RISC 32-bit RISC 5 S-trace support stuff to send upstream. So temperature 62 and increasing. Yeah, we built this with parallels 32, which is of course not ideal. But yeah, that's it for this video. I'm happy that we at least did one thing here, and I hope you learned something, especially how you like have some stuff that is not yet supported, like new Intel AMD stuff, and want to poke around there as a hobby, fun exercise and stuff. And sometimes it's compatible enough to work, or it's just a little bit off, like it still works, but some offset or scaling and stuff. I can compare that to some values. I think the BIOS displayed some temperature. So in the previous video this morning, I said otherwise disassemble the BIOS, right? It's of course also annoying and so on, but that would be for this, like, if you don't have a Windows driver and it at least works in some firmware, then disassemble the firmware, obviously. And guru meditate over the disassembly until you find that. And yeah, so actually I don't need to rebuild that. That is fine. We have committed that. That's it for this video. I think I can pack it away for now and store it there, as until we do the full review or proper video there on the more main channel. And yeah, don't forget to subscribe. I hope you learned something, and see you soon, and have a good day or night.